Hey, thank you for joining me on this home hi-fi system build journey. If you caught my prior episode, I talked about my motivations for putting together a home hi-fi system that's going to be really high performance and cost effective by using primarily used commercial pro sound audio equipment. And so if you haven't seen the first episode, I invite you to hop back and check that one out. If you're interested in following along as I put together this system, well, I encourage you to subscribe to the channel. If you like the videos, please give it a thumbs up and let YouTube know. In this installment, I'm going to talk about the power amplifier that I'm choosing to power this system. And that amplifier is an iNuke, a Behringer iNuke 6000, specifically the NU4 6000, the 4-channel version. And am I choosing this amplifier because it is the ideal amplifier for home audio? No, not really. I think it's going to work well, but I don't think it's the ideal amplifier. If I had to purchase an amplifier for this application, I may well purchase something different. But I have this one, and of the amplifiers that I have, and I've collected more than a few, I think that this one fits my needs best. I have other amplifiers that are much nicer amplifiers than the iNuke, that cost more, that have a higher tier of specifications, that might be argued are better sounding, maybe. But the iNuke, this one, has the features that really make it a good fit for this application. And those features are primarily that it's a 4-channel amp. And I need 4 channels of amplification for a bi-amplified audio system. The bi-amplified system has a separate amplifier stage for the mid-range driver and for the high-frequency driver. And so if I have 2 speakers and I need 2 amplifiers per speaker, well, an amplifier box with 4 gives me everything I need in one box. I have some other 4-channel amplifiers that are possibly nicer, better, more expensive amplifiers than the iNuke. But those other amplifiers that I happen to have don't have speak-on output connectors. And my loudspeakers use speak-on connectors. And because this amplifier box has speak-on connectors, that means that it'll be a nice, neat install. So I can just go from the speak-on output connectors with 1 cable to each box, because 2 of these connectors are NL4s, meaning there are 2 amplifier stages that are attached to that 1 connector. So with 1 cable coming out of here, I can go to the loudspeaker cabinet and provide signals for both the mid-range driver and the high-frequency driver. And it's a nice, neat install with just 1 cable going from the box to the speaker. I like that. Also, being a 4-channel amp, I only need 1 unit, so that's only 1 power switch to operate. It simplifies the system, in terms of user operation. And it only requires 1 amplifier unit, which will save me a little bit on power when things are idle. I could do this install with a pair of stereo amplifiers. But if I have a pair of stereo amplifiers, I then have 2 amplifiers running at idle, most likely drawing more electrical power than just 1 box. And so I thought it would be nice to just simply have 1 box on the shelf drawing less power than 2 and simplify the wiring. And so this is a nice package for doing the audio system. One of the obvious concerns of this amplifier is it going to have good enough sound quality? And my assertion is, yeah, I think it will. All of the electronics that are of mid-tier and above these days are offering pretty darn good performance. And we can look at specifications and draw some conclusions, but we also have to keep in mind what we're really capable of perceiving. For example, if an amplifier has 1% distortion, I think that's probably about the point where most of us would be able to maybe discern that there's a little something up. At 1% distortion, if that was a big bowl of soup that we were eating, that means that for every 100 spoonfuls of soup that's in the big bowl, there's 1 spoonful of bitter soup. So 1 out of 100, if that was all mixed up and we tasted it, I think most of us, unless you're a culinary expert, would probably taste that soup and go, yeah, pretty good soup, yeah. There might be just a little tiny bitter aftertaste, maybe, but still pretty good soup. If it was just 1 drop out of 100, 1 spoonful out of 100 of bitter soup into the bowl of good soup, would you notice? Maybe. And that would be 1%. Modern amplifiers are a whole lot better than 1% distortion. Let's say it's 0.1%. That would be the equivalent of 1 spoonful of bitter soup in a big bucket of 1,000 spoonfuls of good soup. Would you notice 1 out of 1,000? Probably not. And an amplifier with 0.1% distortion, that's possible, but I would actually expect most equipment these days to perform even a little better than that. So even on the outside chance that this amplifier is at 0.1% distortion, and like I say, I would expect it to actually beat that number, but assuming 0.1. And then if we had another one beside it from a different model that was 0.05% distortion, even better, we might conclude that the one with the lower distortion is a better amplifier, better sounding amplifier. But if we can't even hear the artifacts of this one, well, we're certainly not going to hear any artifacts from the other one either. So I think we get to a point of diminishing returns. Now, of course, the behavior of the amplifier has to be good in multiple ways. It has to have low harmonic distortion, low intermodulation distortion, the ability to reproduce transients accurately, high damping factor, good dynamic range, low amounts of background noise, high signal to noise ratios, and so forth and so on. And so, how does this amplifier stack up? I don't think that it's world class, but I do think it's very good, and the experience from other people who've done this has been positive. And so I think it represents a really good value as a high performance, although perhaps not world class reference level performance, but high performance amplifier that is budget oriented. So we'll see. I'll put this into the system, we'll take a listen to it and see what our objective performance is, but my anticipation is that it's going to work out just fine. Let's talk just a little bit about what this amplifier is and why it's such a flexible unit. This is a 4-channel amplifier, and on the back side of it there are some configuration switches that let us adjust some properties. Some of the switches are a built-in crossover, so you have the ability to have, in a pair of channels, have one channel produce low frequencies, 100 hertz and below, and the other channel provide the high frequencies above 100 hertz. So with the built-in crossover, you could drive a subwoofer and your main speaker. That's convenient. I'm not going to be using that, however, because my crossover points in these boxes are between 800 and 2 kilohertz, depending upon the box I choose and my taste. But that's where I'm going to have to cross over between the mid-range speaker that I'm driving and the high-frequency speaker. And my subwoofer is a separate system that's a powered subwoofer, so that it doesn't get involved in this. So I'm not going to use the built-in crossover feature, but it's a nice feature to have in the amplifier. The other switch that we have over here allows us to bridge channels together. So this amplifier in standard mode gives us 4 outputs and 4 inputs. So you got 4 independent amplifiers in the box. Or you could choose to bridge pairs of these channels together if you wanted to. So you could have 2 of them as independent amplifiers and then the other pair of channels bridged together into one single higher powered channel, thus making it a 3-channel amplifier. Or you could configure things where you bridge both pairs, and so both pairs of outputs become one single output, and that turns this 4-channel amplifier into a stereo amplifier with bridged amplifier units within. And of course, in that bridged mode, we're going to get 2 channels at much higher power level than we would have with the 4 channels. The 4 channels are capable of approximately 450 watts each into 8 ohms, or maybe as much as about 600 watts into 4 ohms. And if we bridge them together, we bridge a pair of channels together, we can achieve maybe about 1,000 watts into 8 ohms. So it could be 2 channels at 1,000 watts each, or 4 channels at about 450 watts each. It's a lot of power. So what we have inside of this box, inside of a iNuke 6000 box, is actually 2 iNuke 3000 amplifier units. Well, essentially, basically, that's the circuit. So an iNuke 3000 is an amplifier like this, 2 channels, at about 400 some watts a piece. And so the iNuke 6000 is a pair of iNuke 3000s. I guess that makes sense. Now, if we consider an iNuke 3000 is about 400 watts per channel, or maybe 600 watts at 4 ohms, and I do 400 plus 400 or 600 plus 600, I don't come up with 3,000. So I guess that 3,000 number isn't the number of watts. That's a little bit confusing. But anyway, at any rate, a lot of power. So then, what is this one? This unit right here is an iNuke 6000, but the standard version of the iNuke 6000, not the 4-channel version. This is the stereo version, 2 channels. And so the question is, what's the difference? And the difference is that these two are darn near identical to each other. They're both iNuke 6000s, meaning that they are both 4-channel amplifiers, or a pair of iNuke 3000s in one box, basically, essentially. And so in the 2-channel version of the iNuke 6000, what we have actually are 4 amplifier units, and 2 of them in pairs are bridged. So we have a pair bridged and a pair bridged, and those bridged outputs are the left and right output of the 2-channel version. Now, if you've seen my prior videos, you know that I'm generally not a huge fan of bridging amplifiers. And the reason I'm not a huge fan of bridging amplifiers is because I feel in a lot of cases the manufacturer engineers the amplifier intending it to be a stereo amplifier. And they extend the bridge feature out with some conditions, saying it's a good stereo amplifier and it's capable and rugged enough to be run in bridged mode as long as you don't put too severe of a load on the amplifier. So the amplifier may be rated to comfortably drive a 4 ohm load in stereo, but the bridge spec says a maximum loading of 8 ohms. Don't go below 8 ohms if you're running bridged. Or maybe the amplifier can drive 2 ohm loads, but only a 4 ohm load in a bridged configuration. And so because of that, I'm often somewhat reluctant to use amplifiers in bridged mode because I feel like the amplifier really isn't engineered to run that way, but it's within the scope of acceptable loads on the amplifier as long as you don't go too crazy with your loads. However, in the case of this amplifier, it was designed right from the ground up to run in a bridged configuration, and it has ample current drive to do it well. And so in that case, since they designed it to run that way, and it's capable of driving a low impedance load in bridge configuration, it has the current capacity to do so and the cooling to handle that situation, sure, I'm fine with it. So these two units are almost identical inside. It's just that the 2-channel version is permanently wired up in bridge mode, whereas the 4-channel version has a switch that lets you run it as a 4-channel amp or a 2-channel amp. So that makes the 4-channel amp pretty configurable and pretty capable. So darn near the same amplifier. And as you can see, they occupy the same chassis. They have the same cooling fans and everything. They're very similar to each other. And about the same power specs if you work it all out. One of the biggest detractors of these amplifiers is their noise. And I'm not talking about noise coming through the speakers, like background hiss and hum. In my use, they've been pretty darn silent in that way. But I'm talking just simple mechanical noise from the fans. These fans move quite a lot of air through the amplifier. It's a powerful amplifier putting out up to 1,000 watts per channel, or in 4-channel mode, hundreds of watts times 4. And the amplifiers are very efficient, so they don't make a whole lot of heat considering the power level, but still, that's a big power level. That's going to create some heat. And so we evacuate that heat with these fans, and the fans that come with the unit move a lot of air. They are rated for over 50 cubic feet per minute. And so when the system is running, it's pulling in a whole bunch of air from the back side and blowing it out the front panel. And that's a nice configuration because it doesn't build up a bunch of heat in the back of your equipment rack. It sucks in the cool air from the back of the rack and blows it out into the front, where usually the air doesn't get trapped, so it can cool nicely. And with the stock fans in this unit, I think it has ample cooling. I've worked these amplifiers with rock bands where I've pushed them nearly to the limit all night long. And at the end of the evening, I come up and check the amplifiers, and they are just mildly warm to the touch, just barely warm. So these digital amps are really efficient, and with the amount of airflow that the fans provide, it keeps them completely reasonably cool. But those fans, they move a lot of air, and they make some noise. And if you're using the amplifiers in a commercial application like powering your band or for sound reinforcement within a venue, you're probably never going to hear those fans over the ambient background noise. But in a home situation where it's in a quiet room, you may well hear those fans from the other side of the room. And the fans not only make air noise, but they also have a bit of a buzzy characteristic to them, which I think might have to do with digital signaling in the amplifier, which is a digital control pulse that's controlling the speed of the fans. And there's a thermal sensor in these amplifiers that controls the fan speed. So when the amplifier is cool, it runs the fans at a moderate speed. But if the amplifier does get hot, it's going to turn up the speed of the fans. And then if the amplifier gets very hot, it would shut itself down and go into protect mode. So in order to make the amplifiers a bit more home friendly, I wanted to put quieter fans into the unit. And if you look around at people who have done this modification, it's a very common modification where people replace the fans in this unit with computer-style fans, which are readily available. And there are some fans on the market which are much quieter than the built-in fans that Behringer provides. The fans that you need to get are simple computer-style fans that are like this, which measure 80 millimeters by 25. Pretty typical fan. And the fans that are used in these units are 2-wire fans. So it's just 2 wires coming off the fan to a small plug like that. A lot of computer fans have more than 2 wires. They have multiple wires, and the other wires are a sense signal to tell the computer system what the exact RPM speed of the fan is. But this unit doesn't sense the actual fan speed. It does adjust the voltage and turns the voltage up and down depending upon its temperature situation, but it doesn't get feedback from the fan. So it just uses a 2-wire fan. Now, a lot of people replace the fans in these units with some other fans that are much, much quieter but move less airflow. So the stock fans move about 50 cubic feet per minute. Some of the popular replacement choices move 25 to maybe 30 cubic feet per minute. And in a home theater or home hi-fi situation, people report that that's perfectly sufficient because you're not pushing the amplifier super hard, you're not generating that much heat. It doesn't typically get that warm to begin with anyway. And so those lower speed fans, they work fine and they're quiet, and it's a good upgrade or fix to the fan noise. I'm a bit reluctant to go swapping out the fans because I want to make sure the amplifier always has ample cooling, even if pushed hard. So if you're using it in a commercial situation where the little bit of fan noise isn't a problem, I wouldn't change out the fans. I'd keep the stock fans in that move lots of air. But in my situation, I want to replace the fans, but I don't want to reduce the amount of airflow too much. And so the fans I chose aren't the very quietest choices, but they're much quieter than the originals, and my fans move about 40 cubic feet per minute. So not quite as much as the stock fans, but still quite a bit, which I think is ample for keeping the amplifier cool, even under pretty demanding situations. And so what I've done is I've replaced the fans in the 4-channel unit, and I have not yet put new fans into the 2-channel unit. But like I say, both of these are almost identical to each other, and they both sounded identical, or nearly so, in terms of fan noise when I began the adventure. So I'll let you hear the difference between the 4-channel unit with the replaced fans in it, the upgraded fans, and the 2-channel unit on top here with the original stock fans. And to replace the fans, it's super simple. All you need to do is remove the top cover. There's 6 screws on top, and you just pull that cover off. And then there's 4 screws on each of these fan grills, and just pull them out, and then the fan will be loose, and you can just reach in and lift the fan out of the unit. It is plugged into the power supply board with this connector right here. So just lift the fan out, unplug it off of the circuit board, drop in your replacement fan, and if you get an 80 millimeter by 25 millimeter fan, it's the exact same size, so that'll just drop right in. Pop in your 4 screws with this cover on, and you can mount the new fans, and then just fish over the wire and connect these connectors onto the power supply board to power the fans. Be mindful of which pin the red wire goes on so the fans spin in the proper direction. And that's all you need to do to change out the fans. The fans that I chose, which I'll provide a link down below if you're interested in grabbing some, use the same connector on them as the originals. So it's a plug-and-play situation. Just unplug the old one and plug in the new one. It's about a 10-minute job to pop out the old fans, drop in some new ones, cover it back up. So let's plug these guys in, and I'll let you hear the difference from the old fans to the new fans. And like I say, I didn't choose the very quietest fans. You can get quieter fans. So I'm still going to have a little bit of background noise, but I think sitting in the other side of the room, it's not going to be quite so obnoxious. Certainly not as much as the original fans were. So let's spin these around, plug them in, and let's take a listen. So let's power on the 2-channel amplifier with the original fans. Not too bad, but certainly not silent. And with that slightly buzzy, raspy sound, I think you'd hear it from the other side of the room. Now, the replacement fans aren't perfectly silent, and they have a little bit of that buzzy sound too, but I don't think as much. So let's now switch over to the updated fans. So you can see, not silent, but a lot better. So that's the amplifier that I chose and why I chose it, primarily because of the amplifiers that I happen to have on hand. I think this one has the features that will make the installation most simple, most neat, and convenient to operate. And I think it's going to perform just great. So we'll find out. Hey, thanks for following along in this journey. I hope you continue to hang out while we move forward and assemble the pieces to build this audio system. In the next upcoming episodes, I'm going to be talking about the loudspeaker choices, the drivers that are within those speakers and why I chose those drivers, and the setup of the electronic crossover system and speaker management system, and the tuning of the room with equalization. And then we will talk about the preamplifier that I chose for this build, and we'll take a listen to the system, see what we think. So I hope you hang out over the next few episodes as we assemble these pieces and hopefully achieve audio nirvana. Hope you found it interesting, informative, and maybe even educational. And I'll catch you again soon on another upcoming episode. Please consider subscribing to the channel so you're notified when new content comes down. Take care.